Yes, this is video. Hi. Welcome to Monday. I've got one of my old coffee mugs from a race. It gets a little hot because there's no... This is actually super awesome, but I'm going to wait till the coffee gets a little lower so I'm not burning my fingers to tell you about it. Got some new markers. Very exciting. I think we're going to go with blue, although I've got black over here also. Little Mr. Green is still here, but, we'll see how he does. So we've been marching toward just this basic idea of this method of algebra, okay? And we need a lot of skills to be able to do that. When you want to play any sport, pretty much, there are basic skills as a human being that you need to be able to manage the world. Standing, walking, motor skills, finding where your mouth is versus like your eyeball if you're trying to eat or drink coffee. Speaking, all these things are articulators. We learned how to do that. Now, we pretty much learned how to do that before we even remember, but it's part of the playing field of life. And again, there's a reason I'm speaking English and not Italian or Swahili or any number of other languages that exist and have existed on the earth. I'm not speaking Latin because people just don't speak it so much anymore that it, as we say, died. Although my son is still learning it. So, there are building blocks to be able to understand math. You have to know our number system, our numeration system, okay? You need to know what the decimal means. You need to know what fractions mean. Whole part, fractional part. You need to know what number sets are. And those are all things that we went over. And then we talked about a little bit about the history of algebra we know today, which there's more to it. I mean, there's just always fun with that. Okay, so let's think about what we're doing when we learn about anything that we're trying to solve. So I had said this in a previous video for a hot second, but let's just take our little fun howdy do, okay? And say if I have 5 plus something I don't know, I had 5 of something. There's like a pile of things that are in there, and now I have 8, okay? It's pretty straightforward, and most of us get that. If I had 5 of something, my dad comes over and drops stuff off, and now I have 8 of that thing. How many things did my dad drop off? Well, 3, right? We kind of just intuitively get that, right? I had 1 marker, now I have 5. Well, 4 came in my expo pack, right? Why are we writing this down? We write it down for the same reason that I speak to you now versus write a story or read an article. It's dissemination of an idea and also a complication of an idea. And it's easier to go back and read something, cheers, than it is to have to bear with that idea explained to you. A lot of times we lose track. So we don't usually use question marks, right? We use variables. So let's get to the heart of what an equal sign is. So this means it's the same. So every algebra starts out as a simple thing. I'm going to go with 5 again. 5 equals 5. Plain and simple. And we're going to build on this. Let's say I say I'm going to do something silly. And I'm going to add that x, right? 5 plus x equals 8. Okay? I added a phantom added x to both sides. But x is really 3. But on this side, I wrote a variable, and on this side, I actually just added 3. Okay? And in fact, I can do an intermediate thing and say 5 plus x equals 5 plus 3. Okay? Just so because I want to show you how it builds, because then when we solve, we undo. Well, what if I doubled both of these things? So I want to double this whole phrase, which means I have to have a parentheses. So now this side I don't know right now. Well, what if we started with that, right? And we go backwards, and we figured out this weird thing that we added was 3. Okay? I'm sure you say, it's such a waste of time. I know how to do this. Why am I writing it down? We're writing it down for practice. Practice. So you'll notice I added parentheses because I wanted to double the whole thing, which we're going to talk about, right? Okay, so when we solve, we like to do this thing. In algebra, they'll often say inverse operations to solve. So the inverse of adding, the undoing. Inverse means you undo it, right? I am holding the board. I set it down. Pick it back up. It's back to where it started. Those two operations inverted themselves. Here's another perfect one. The cap is off. The cap is on. Cap is off. Those operations inverted themselves. The on-off was an inversion. Okay? So when we invert addition, why don't we undo addition? We subtract, right? How do you undo subtraction? You add. How do you undo divide, right? How do we undo division? We multiply. Oh, I really slanted that. I kind of like it, though. So we know how to do this, right? We know how to do our inverse operations. We can't forget this, though, and they are linked. It goes right back to our number line, okay? So I'm going to pause this because I know a lot of people, students, it just gets too long. In the next video, I'm going to do 2 examples, okay? Fantastic.